Okay, girls. So today we're going to explain motion. We're going to talk about force and motion. Okay. I just want everyone to have a notebook to write in. Okay.
Yes, I right.
Okay. So
I
in,
have it.
okay. So dealing with our class as if you are in the class. You are in a live class. Okay. Okay. It will help you concentrate, help you visualize and record everything we write. We explain. Okay.
Okay.
Mm. Okay. So, Fatima, you are here now. You have your notebook.
Yeah.
Okay. So today we're going to talk about motion versus motion. Okay. So in physics we study motion and what's meant by a body in motion. What meant by a body in motion? Does anybody know anything?
Mm,
How can you describe a body in motion? It means that the body changing its position as time passes. So if we have a car,
yes.
the car is moving, time passes, and the car is moving. So here, body changes its position as time passes.
Time passes. Yes.
Okay. So what's meant by a body at rest? If the body in motion, it means that the body changing position as time passes. So what if the body is at rest? Or stationary, or standing still? Hmm.
Stationary. It means that it is.
Hmm. At rest or stationary? Any idea? Fatima, any idea?
Like what is meant by stationary in
Yeah.
physics?
Hmm. At rest or
It means it
Hmm.
means it's like it's not moving, it's still.
Yes. So when we describe that the body changes its position as time passes. So if the body is at rest, if the body doesn't change its position as time passes, right?
At rest. Yeah.
Yes. Okay. So at rest, body doesn't change position as time passes because time never stops. Huh?
Yes.
Okay. Okay. So have you finished the copying?
Yes, Miss.
Okay. So when we deal with motion, what are the terms do you think we use to describe the motion of the object? If I'm describing the motion, so what are the terms I'm going to use?
Mm,
Sorry, miss, I didn't hear you.
What are the terms we use when we describe the motion of the object?
Newtons?
Newton is the measuring unit of force. Now I'm talking about motion, not the cause of motion, because forces are the cause of motion. But here I'm talking about motion.
Oh, motion.
Uh,
Meters per second.
meter per second is the measuring unit of speed, right? So we use the term speed when describing the motion of the object. What else? Speed,
mm,
uh, velocity,
its direction.
okay, the direction of motion, acceleration, right?
Yes.
displacement, time, right? All of
Yes.
the terms we use to describe the motion of
The
the
motion.
okay? Distance, displacement, velocity, speed, acceleration, time. Let's study the first distance and displacement. So distance and displacement. Okay. Actually, distance and displacement both are length. Okay. So they have the same measuring unit. Do you know what is the measuring unit of length? The SI unit?
Uh,
What is the measuring unit of length?
I think meters.
Meters, right? The SI.
meters. Yes. Meter.
Meter, meter. Okay, so meter is the measuring unit of length. Okay, so okay, so distance and displacement, both are length, both are measured in meters. Okay, but what?
Yes.
Yes. Yeah. You have any questions?
No, no, no.
So distance, what is the main difference between them? The distance is the
Vector.
actual
The vector.
length covered by the object. Okay,
Yes.
that is the actual length covered by the object. But displacement is the direct length between the starting point
Ending point and the ending point.
and
And
point. برافو يا لمار. Okay. Okay. So because distance is the actual length covered by the object and displacement is the direct length, so we describe distance or we classify distance as a scalar quantity.
scalar quantity. Yes.
Displacement is a vector
Vector
quantity.
quantity.
You know what's the difference between scalar and vector?
Can I
Yes.
say this?
Okay. Lamar? Okay.
That the scalar it has only magnitude, while the vector it has magnitude and direction.
Excellent. 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 Fatima, can you give us another examples about scalar and vector?
Velocity is a vector, and speed is scalar.
Bravo. Bravo. Huh? And velocity is a vector, right?
Yeah, I said
Okay.
velocity
Yes.
is vector.
Okay.
Is a
What
scalar.
about mass and weight? Which one do you think it's a scalar and which one do you think it's a vector?
Mass is vector and weight is scalar.
As vector.
Lamar.
لا 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 الماس هي السكيلر والويت
Yes,
الماس سكيلر and the weight
a vector.
is a vector. Yes.
Okay, because mass is dependent on the amount of matter in an object, but weight is a force, and force has direction.
Yes.
It's fully described when you describe the direction. Okay, so back to distance and displacement. Bravo عليكم, good girls. Back to distance and displacement, we said that distance is a scalar, but displacement is a vector. Okay, let's have an example to show more about the difference between distance and displacement. Here you have an object started its motion at point A, and then moved to point B to cover 10 kilometers. Okay? So here, if we're asked to find the distance, Fatima, what do you think is the distance from A to B?
Oh, pardon?
Sorry?
I didn't hear what you said.
Okay, what is the distance from A to B?
10 kilometers.
10 kilometers, right, bro. 10 kilometers. Okay. What about displacement? What do you think the displacement here will be?
برضو 10.
Yes, 10 kilometers, but we have to mention what? Huh?
So if we go back from 8, then it'll be 0 again.
Yeah, but here I'm talking about if you said that displacement here equal 10 kilometers. Have you here fully described the displacement, or you have to mention the direction?
Right or,
10
or
kilometers
left?
right.
Yes, okay.
Right.
You have to mention its direction. So scalar is 10 kilometer. So displacement is 10 kilometer. Displacement 10 kilometer, right.
Right.
Okay. Okay.
Yes.
So now the body moves in the opposite direction and covered 2 kilometers. Okay, to reach point C. In this case, from A to B, then to C. What do you think is the distance will be, Lamar?
Miss, can you please repeat again, please, what you have said, please?
Okay. Here in this, now the body started its motion at A, moved to B, then to C. So what is the displacement covered by the object? The distance.
will
What is
be
the distance?
10 minus 2.
You're talking about distance or displacement?
لا, 1 second.
Mm.
It is
12.
the distance, which is
Yes, Fatima. Excellent. The
12.
distance, yes, okay, because we said before that what distance is the actual length covered by the body in any direction. So we have to add all the length covered by the body, okay?
Yes.
So here distance will be 10 plus 2. It will be
Which is
12
12.
kilometers, okay? So what about displacement?
8 kilometers.
Sorry?
Would it be 8?
8
kilometers.
excellent.
8
8
will be,
kilometers.
which is, yeah,
Right.
to the
Why?
right.
Oh, because here the body started its motion at starting point at A and ends its motion at C. So, and back to the definition, it's the direct length between the starting point and ending point, regardless how the body covered this length. Okay. Here we concern only about the starting point, where the body started its motion and where the body ends its motion. Okay. Okay.
Yes.
Now the body back to A again. Okay, so if you're asked to find the distance will be what?
20 kilometers, but the displacement will be 0 kilometers.
20 kilometers here, but the displacement
0.
0 kilometers.
excellent. The displacement equals 0. It's 0 because the starting point is the same ending point. Here, any
Yes.
question here?
No, thank you.
Have you copied all of this?
Yes.
Okay, Fatima?
Yep.
Okay. Now let's talk about speed and velocity. Okay. What is speed? The distance,
Over the time.
yes, covered per unit time. Velocity, huh?
ممكن أقول أنا miss?
Yes, اتفضلي, sure.
It's a vector quantity and it is how fast and in what direction something is moving.
Excellent, excellent. So velocity can be described as it's a vector quantity. And it's represented by
How fast and what direction? Kilometers per
Yes.
hour or meters per second.
yes. Okay. How fast the body is moving in a certain direction. So as direction is mentioned here in the definition of the velocity, so we can deduce that velocity is a vector
Vector quantity.
defined by magnitude and direction. But speed, here we talked about the distance only. And distance
So
is
which
a
is
scalar.
magnitude, which
So-
is scale.
So it's a scalar quantity. Okay?
Yep.
Yes.
So both are length per time. Okay? Both have the same unit, which is the SI unit of speed and velocity is meter per second. We know that there is another units like kilometer per hour, mile per hour, but we stick to the SI units, okay? Which is meter per second. Clear?
Yes.
Okay,
Thank you.
okay. So how to represent speed and velocity on motion graphs, okay? So graphing speed, okay? We use distance time graph, okay? Because speed is the gradient of distance time graph, okay? You know what's meant by gradient? Gradient of any graph. How to find the gradient?
Rise over run.
Excellent. Rise over run.
Overrun.
Y over a change in x, which is rise over
Mhm.
run. Okay. So the rise over run or a change in y-axis over a change in x-axis represents what? Represents speed. Okay.
Yes.
And we can also use speed time graph to represent speed, the change in speed over the change in time. Okay. But the slope of distance time graph represents the speed. Okay.
Okay.
So here, if we have an object that covers equal distance in equal intervals of time, okay, which means that in each second, the body covered the same distance. Okay. So here we will have a straight line graph starting from the origin. So here, what does this graph represent? This graph 1, it represents what? A body is moving with constant,
Speed.
constant speed. What's meant by constant speed? It means that the body covers in equal intervals of time. If we want to describe or to represent this motion, constant speed, on a speed time graph, what do you think it will be? So let's find the speed here first. Speed equals here will be rise over run. So it will be 6 over 3. Okay? Which means 2 meters per second. Clear? Does anybody have any problem in this?
No.
No.
Okay. So here the body is moving with constant speed 2 meters per second. Can we
Mhm.
represent on a speed time graph? If we have here. On this graph, speed time graph. How can we represent this motion, this graph of constant speed by the same value on a speed time graph? What do you think the graph will be?
It will be like this.
Hmm.
It will be like this.
Yes, excellent, excellent.
Yes, Alhamdulillah. Yes.
Alhamdulillah. Okay, you got it, ya Fatima? Okay, here we have a body is moving with constant speed. So the body
Yes.
is all the time all the 3 seconds, during the 3 seconds with constant speed. It means that
Speed.
time passes, but the body is moving with constant speed. Okay, so here,
Yes.
constant
Speed.
speed.
Mm.
Clear?
Yes.
Does anybody have any problem?
No. But can I
Any-
screenshot it first?
Sorry?
Can I take a screenshot of this?
Yes, but and I asked you to write. I just want you.
I'm writing. I'm writing this. I just need to.
Okay.
Thank you.
Even if you didn't write during the session, after the session, I will send you the recorded session. Okay? So please make a notebook. Make physics notebook for you. It will be a reference. Okay?
Okay, I have one.
Okay. So record the session in your tablet. Okay? So here, let's continue talking about graphing. Okay? What if we have a graph like this? It's a distance time graph. I just want you, whenever you see a graph, please check the axis. Check the axis. The first thing your eyes should look to. Okay? So
Okay.
distance time graph, because even if the two graphs have the same shape but different labels of the axis, they will represent completely different motion. Okay? And we'll see this today. So here, what does this graph represent?
Constant speed.
No. Wrong.
Wrong.
Yes, it's a distance time graph.
Graph. Okay.
Time graph. So what does it represent?
Distance over time.
Yes. Okay.
So it represents speed.
Sorry?
Just represents speed.
Yes. Okay. Is the body moving now?
No.
What is the slope of this graph? Isn't it 0?
Yeah.
The gradient here equals what?
0.
0. So what about the speed?
So when the gradient is 0, the speed is 0.
Excellent. What does it mean? What does it mean if the speed of the body is 0? What does it mean?
It means that it is not moving.
Yes. So
So
here
it's
the body is at.
constant speed.
No, it's not
Rest.
constant speed. Speed equals 0. Speed equals 0. The body here is at rest.
At rest.
Oh, yeah.
Okay.
The body is not moving. The body here is
Not
standing
moving.
just at 4 meters away from the starting point. So here, if we consider the spin 0 is the starting point. So here the body, with reference to the starting point, the body here is 4 meters away from the starting point, and it's not moving for 4 seconds. For these 4 seconds, the body is not moving. The body is at rest. Okay?
Yes.
Okay, which is completely different from the graph you draw in the last screen. You know,
Okay. At rest. It is at rest.
here it's a speed time. Okay, and they seem to have the same shape, but do they represent the same motion? Graph 1 and graph 2. What about graph 2? Here, what about graph 2? Can you describe the body, the motion of the body at graph 2?
At rest.
It's a speed time graph, honey. It's a speed time graph. But here it's distance time graph. So here the speed here has a value. If the speed here has a value of 4, but it's constant. Okay? So the body here is moving or is not moving in graph 2?
It is moving.
Excellent. Moving.
It is moving
Yes.
with a constant speed.
Bravo. Moving with constant. Fatima, you got it?
Yes.
Yes. Anybody had any problem in this?
مش بس هو يعني هو what is the difference between them يعني how do you know that this one it is at rest and the second one it is moving with a constant speed? Because I want to know this point.
Okay. You first observe that what is the quantity represented on y-axis. Here on the graph 1, we have distance on the y-axis. Okay? So
Okay.
here, the value that is represented on the y-axis is constant here. It's 4. It doesn't change. It doesn't increasing or decreasing. Okay?
صح, yeah.
Okay, so the body is at rest. The body is standing still at a particular point, but the body doesn't change its position.
صح, yeah.
Oh,
I got it.
the second graph, what is represented on the y-axis?
It is 4.
What is this? What is the physical quantity represented here on the y-axis?
What?
It's what? It's a speed.
It's the speed time graph, so yeah.
Speed. On the y-axis, it's a speed. Can you ask yourself here, what is the value of speed here? What is the value?
4.
It's 4.
4.
Right?
Yes.
Is that 4 changing?
Yes.
It's changing? It's 4. It's changing?
No.
It doesn't change. So it means that the speed has value. When the speed has value, it means that the body is moving. The speed here is not 0 to say that the body is at rest. The speed here is 4. So it has value, but it's a constant. That's why we say that the body here is moving with constant speed. Clear?
Yeah.
Does anybody have any problem?
No.
Okay, Fatima?
I'm good, thank you.
Yes, okay. And we have here Mariam, right?
Yes.
Okay, hello, Mariam.
Hi.
Okay, welcome. Are you following us?
Yeah.
You have any problem? Everything is clear?
Yes, everything is true.
Okay, have you finished copying, girls?
Yes, miss.
Okay, let's move to another challenge, a new challenge. Okay. Here, distance, time, space, and here we have speed, time. Here, this graph is consisting of 2 sections. Okay. The graph here is consisting of 2 sections. This is the first part, and this is the second part. And here, the first part, and here is the second part. Apparently, they have the same shape, right?
Yes.
Do you think they have the same conditions or they describe the same motion?
No,
No. Why?
because one of them is distance time, but one of them is speed time.
Speed time graph, yes.
Yes, because they have different labels of the axis. Okay.
Of axis, yes.
Yes. So here, this is 4, this is 6, and here, this is 6.
Excuse me, ma'am. Sorry to interrupt.
Yes, no problem.
Sayyida Fatima is here. Alhamdulillah, she can join you.
Yes.
But before you continue, just want to ask a question. So
Yeah.
this is the first topic of the curriculum. Is it so?
Yes, yes, course and motion.
Okay, and you are going to cover the whole syllabus by which month?
By which month?
The whole syllabus. I'm talking about the whole course.
The whole syllabus in February.
February.
Yeah.
Within 3 months, you're going to teach all the topics, around 21 topics?
Sorry, I can't hear you clearly.
I mean the whole syllabus according to the GCSI syllabus.
Yeah.
Are you going to cover it within 3 months?
Yes.
Oh, that's
Sure.
fast.
Okay.
Okay, let's see. So Fatima is here.
Because after this, we start solving the hash tables and everything.
Sorry, I couldn't get you. The voice was distorted.
Okay, because after finishing the syllabus, we start solving past papers.
Oh, okay. Okay.
Okay.
Thank you. So Sayyida is here. Say hi to you.
Yes, welcome.
Salam karo.
Hi.
Hi, Habibti. Welcome. How are you? Welcome back from school.
Thank you.
Okay. Okay. So here we have distance time and speed time graph. Okay. Can you describe section A, section B, A, B? Here in graph, first graph, section A, what does it represent?
The body is at rest.
Excellent. The body here is at rest. Right, section B.
The body is
Going
decelerating.
backwards. The body is
Excellent.
decelerating.
No, it's not decelerating. Here, the body is
Accelerating.
moving with constant speed in the opposite direction or returning back to the original. Okay? So in B, body moves with constant speed back
to the origin.
to original point. Okay? Let's talk about the second graph. At A, what happened?
Moving at constant speed.
Excellent.
At constant speed, yes. Speed.
At B, what happened?
Decelerating.
Excellent. Here the body
It's decelerating.
increasing the speed. Yes. Excellent. Excellent. Good girls. Okay. Finish this.
1 second.
Yes.
Okay.
I just need to. Okay, Tamam, thank you.
Welcome. Okay. So again, the last challenge about graphs. Okay. For the first graph, what about A? Part
Moving
A.
forward.
Sorry?
Yeah. Moving forward.
Moving forward with constant.
It's speed.
Excellent.
Yes.
Okay. Mariam? Mariam?
Mariam's on the A.
Yes.
Yes, okay. Question, part B, what does it represent?
It's at rest.
Excellent. Okay. Fatima? C?
Moving backward with constant speed.
Excellent.
Moving backward. Yes. Constant about speed.
Yes. Okay, for this graph, Sayeda, part A, what does it represent?
Yes, part A represents accelerating speed.
Yes, body increasing the speed, accelerating, as you said. Okay, Lamar, part B here.
Yes. B. B. It is. It is moving. No. It is.
Yes,
It is moving with constant speed.
excellent.
Yes. Alhamdulillah.
Moving constant speed.
Speed.
Okay. Mariam, C.
It's decelerating.
Excellent. Okay. Good girls. Have you copied?
Yes, miss.
Okay. What if we have distance time graph and the graph is curved like this, or the graph is curved
Means
this?
it's slowly accelerating.
Sorry?
Slowly moving forward.
Distance time graph and it's curved upward, it means that the body increasing
Yes.
speed, not moving
Yeah.
with constant speed, because if it was constant speed, the graph would be a straight line, right? But here, as time passing, the distance covered increasing. So here the body increasing speed, or we can say accelerating.
Yes. Accelerating.
Yes, what about the second graph? If the
It
graph is
is
downward, it means that the body
decreasing.
decrease.
Decreasing.
Excellent.
Or decelerating.
Bravo, Lamar. You are
Thank you.
perfect today. Okay. Okay, guys?
Yes, miss.
Okay. Have you copied?
1 second.
Okay.
Okay, then.
Let's talk about acceleration. At the very beginning of the session, we said that motion described by speed, by distance, is displacement, and we covered this. Speed, velocity, and we covered this. Now we're going to talk about what? Acceleration.
Acceleration.
Okay. So what is acceleration?
Like the definition?
You know, any ideas about acceleration? Who knows?
Yeah, I know.
Hmm?
It's the rate with
Acceleration is the
Mhm.
rate
Rate of a change.
of
at which velocity changes with time.
Of change.
a change in what?
Velocity.
Velocity.
In
Excellent.
velocity.
Yes. Acceleration is the rate of a change in velocity. Okay?
Yes.
So how can the body change its velocity? By changing what or what?
The initial velocity.
Hmm? How can the
And
body
In the
the
final.
And the
changing in what? In speed, right? And direction, right?
Yes.
Okay, because velocity is a vector quantity defined by magnitude and direction. Okay, so if the body changes its speed, it means that the body changing its velocity. But even if the body is moving with constant speed, but it's changing direction, because velocity is a vector quantity, we can say that the body is changing velocity. Okay? So what's meant by rate? When I say this physical quantity is the rate of change of this another physical quantity, it
Yes,
means,
the time.
yes, okay, it means that a change in velocity over a change in a in time.
In time.
So acceleration is what? A change in velocity over
Change in time.
a change
In time.
in time. This is small triangle called
Delta.
called delta, and it means a change.
Yes.
Okay. Okay. So to solve for acceleration, so a change means that we have initial value and final value. Okay. So it will be V final minus
Verse V initial.
initial over T final
time.
Minus T
minus,
initial.
yes, minus T initial. A change in velocity or change in time. Okay. Okay.
Yes.
So what do you think do you have any idea about the unit of acceleration? What is the unit of acceleration?
Meter per second squared.
Excellent. It's meter per
Second
second.
square.
Okay. So what do you think acceleration is? Is it a scalar or a vector?
Mm,
Hmm? Sorry? Any ideas? Okay, so we said that
Scalar?
acceleration is the rate in a change in velocity, and velocity is a vector. And
Yeah.
if the body changes its direction, it means that the body changes its velocity, so the body changing its acceleration. So what do you think acceleration is?
Vector.
A
Vec-
vector.
It's a vector quantity.
Yes. Sayeda, do you know what's the difference between vector and a scalar?
Yes, Miss. A scalar is a quantity that has only a magnitude but not a direction, and a scalar and a vector is a quantity which has both magnitude and direction.
Excellent, excellent. Do you have other examples about scalar and vector?
A scalar is like length,
Yes.
temperature, and velocity is displacement, and acceleration, and
Yes, are
mass.
vector. Mass is what? Mass is a scalar or vector?
Mass is scalar.
Yes, excellent. Okay. So can you classify distance and displacement, Sayeda? Distance, is that a scalar or a vector?
Distance is a scalar, and displacement is a vector.
Excellent. Good girl. Okay. So the body is accelerating. We can say that the body accelerates if the body speeding up, right? Or slowing down, or changing or changing direction. Okay. Okay. So if the body is speeding up, so what do you think? Which is greater? Its initial velocity or its final velocity? So here, if we have V initial and V final, which sign I should place here? V final is greater or smaller the V initial?
Smaller.
If the body is
VI is less than VF if
excellent.
it's speeding up.
Yes. If the body is speeding up, so V initial is smaller than V final. And if the body is slowing down,
VI is
Yeah,
bigger
it's
than
bigger.
VF.
excellent. Okay, so here, if the body changing direction only, even if the body is moving with constant speed, okay, we say that even the body has constant speed, but it's changing direction. So the body is accelerating. But in this case, it's called centripetal acceleration. Okay. Here, in this case, it's called centripetal
Yes. Accelerate.
acceleration, and it's about the circular motion, and we're going to study it later. Okay. So the acceleration.
Say the word again.
Which is all to the center.
Yes, برافو عليك.
Miss, can you say the word again?
This the last one.
No, Miss, after changing direction.
If the body changing direction, even if the body is moving with constant speed, but it's changing direction, we can say that the body accelerating. But in this case, it's not linear acceleration because the body is not moving in a straight line. Okay? And
Yes.
we call it
Yes.
centripetal acceleration. Yes.
Okay.
Okay, centripetal acceleration is about the circular motion, and we're going to study it later. But now we're studying the linear motion, if the body is moving in a straight line, either horizontally or vertically. Okay?
Yeah.
Okay. And centripetal acceleration and centripetal force, they will be directed to the center
To
of
the
the
center.
where, oh, yes.
Yes.
We're going to study it later. Okay, girls?
Okay, Miss.
Okay. Now we're going to talk about graphing the acceleration. How to graph acceleration. Acceleration equals gradient of speed time graph. Okay? Gradient means, we said before that gradient means rise over
Is
run
overrun
or delta y
over delta x.
delta x. In what? In speed time graph. Okay?
Oh.
Okay, so we can draw some graphs to represent the acceleration. Here is speed time graph.
Yes.
Second one, the speed was 2. Second 2, the speed was 4. Second 3, the speed was 6.
X.
Okay? And so on. So if we draw the graph, if we plotted this graph, it will be a straight line. Okay? Which means that the body here is speeding up. At each second, the body increases its speed by 2 meters per second. Okay? Here's the body increasing speed uniformly, right?
Uniformly, yes.
Okay. So here the acceleration, as we said that the acceleration is the slope here, so it will be 6 minus 0 over 3 minus 0 from the graph. So it will be 2 meter per second square.
Per
Which
second
means
square.
that, because here's the graph is a straight line, it means that the gradient is constant. And the gradient here equals what? Equals the acceleration, right?
Yes.
Here the acceleration is constant, because if you calculated the gradient of each interval, it will give you 2 meters per second square. Okay? Which means that the body is moving with constant what? Huh?
Constant.
Huh? The gradient is constant. And here the gradient equal acceleration.
So it's constant acceleration.
Excellent. Constant acceleration.
Acceleration. Yes.
So here we can describe the graph. How can you describe the graph? The body is speeding up with constant rate. So the body is moving with constant acceleration. Okay? Clear?
Okay.
Girls, all of you.
Yes, miss.
Okay, Fatima, Mariam,
Yes.
Sayeda. Everything is clear?
Yes.
Yes.
Okay. Okay. Let's see here. Here we have a speed time graph, right? And the graph is horizontal. 1, 2, 3. 2, 4, 6. Huh? Can you describe the motion here in terms of speed and acceleration?
Constant speed.
Constant speed. Excellent. So here the body is moving with constant
speed.
What about acceleration here? Huh? What about acceleration? Is the body accelerating?
Uniform.
Can you?
No.
0, I think.
Excellent, excellent. Because here the body is moving with constant speed. And we said that acceleration is the rate of change. So the body has to change either its speed or direction. So we can say the body is accelerating. So the body here is moving. The body is moving, but it's not changing its speed. So here acceleration is what? Equals 0. Why? Because the gradient of the graph is 0. Okay? As simple as that. Clear?
Yes.
Okay. What if we have this graph? What does it represent? What does this graph represent in terms of speed and acceleration?
Deceleration.
Deceleration. Excellent. So the body here slowing down or decreasing, decreasing speed with constant rate. And here we have constant negative acceleration, right? Constant
Yes.
negative acceleration or constant deceleration. Okay? Clear, Yolette? Clear, girls? Is it clear?
Yep.
Yes.
Yes.
Okay. Okay. So if you're asked to find distance covered from speed time graph, how to find distance covered from speed time graph. Okay, here we have a speed time and the body here increasing its speed. And you're asked to find the distance here. The distance here equals area under the graph. The distance equals what?
Area under the graph.
Don't think that we can find the distance by the normal rule of speed equal distance over time. So distance equals speed times time. We use speed equals distance over time, okay, for constant speed, okay?
Constant speed.
Only speed, only. It's the body only moving with constant speed. Do you think that here in this graph, the body is moving with constant speed? In this graph, the body is moving with increasing speed.
Constant speed.
Increasing.
Increasing.
Increasing speed. If you have here a scale, 1, 2, 3, and here it's 2, 4, 6. What does it mean? The body increasing its speed 2 meters per second in each second. So we cannot use speed equal distance over time. Well, what should we do here to find the speed, to find the distance covered from speed time graph? You follow this rule. Area under the graph. It's area under the graph. And it's dependent on the shape of the area under the graph. So here, what does it shape here represent? What is this shape? If we find area under the graph, what does this? What is? Yes. Okay. It's a triangle. So here, area under the graph equals area of triangle, right? Okay.
Yes.
If we have this graph, what is the area under the graph?
Trapezium.
Yes. Okay.
Trapezium.
Yes. Excellent. It's a trapezium. Okay. So area of rectangle here, it's a half time base time height, right? What is the area of trapezium? Can you find the area of trapezium? Or what is the formula used to area of?
A plus B over 2 multiply the height, I think.
Excellent. So base 1 plus base 2 over 2 times height. So on the graph, where is base 1? Here is base 1 from the starting point to this point. Okay?
The ending point.
Where is base 2? Here, base 2. Okay? And we take the reading of base 2 from the x-axis, where it started and where it's ended. Okay?
Yes.
The height, we take the height from the y-axis. Clear, girls?
Yes.
Okay.
Yes.
Let's take an example. Have you copied this?
Yes, miss.
1 second, miss.
Okay.
Okay, done.
Okay. Okay. Here. What is the distance during the first 4 seconds? Fatima? During the first 4 seconds, what is the distance here?
During the what?
The distance covered during the first 4 seconds.
Oh, okay. So it's divided by 4.
What is the shape is taken here?
1 second. Can I just use the equation?
Okay, so first we have to identify the shape under the graph. Okay, so through the first 4 seconds here, what is this shape?
Triangle.
Triangle. Okay, so what is the area of triangle? Half.
Half of times the
Yes,
distance.
multiplied by base, multiplied by height. Okay?
Yeah.
Okay, so half time what?
4 times 8.
Yes, excellent. So it will be 15 meters.
Yeah, 32 divided by 2, which is 16 meters.
Yes, okay, right. Distance, Mariam, distance from 4
Yes.
to 12. Distance from 2 to 12. From 4 to 12, sorry. From 4 to 12.
8 multiply 8.
Yes, excellent. Because here we have, it's what is this shape? It's rectangle, right? So it's length time width. So it will be 8, the depth from 4 to 12. So this length is 8 and the height is 8. So it will be 8.
So 8 times 8.
Yes. Excellent. Okay, so 8 times 8 equals 64 meters, right? Okay.
Yes.
What if you're asked to find the distance from 0 to 12 direct? Can we find it from 0 to 12? Distance from 0 second to 12 seconds. What
Add them together.
Yes, you can add them together and you can use the area of trapezium, right?
Yes.
Yeah.
So in one step, you can find the total distance area of trapezium. So it will be
كده معاه في ايه؟
60 meters.
بس خلاص والله
base
معلش
2
خلاص معاه
over 2 time height. So base 1, here, what is base 1? 12 plus base 2,
64.
base 2, which started here at 4, and ends at 12.
8.
So base, excellent. Base 2 here equals 8. Base 1 is from 0 to 12. Okay, base 2 is from 4 to 12. So it will be 8 divided 2 times height. What is the height here, يا ولاد?
8.
8. Excellent.
8.
Bravo. Okay, 12 plus 8 equals 20. 20 divided 2 equals 10. 10 times
80.
8, it will be 80.
8.
Isn't the total distance, if we added 64 to 16, if we added the area of the rectangle plus area of triangle, it will give us what? 80, right?
Yes.
We
Yes.
found it in one step. If you're asked in this, yani we use the area of trapezium. If you're asked to find the same like here from 0 to 12 directly, and the shape is the trapezium, so it's easier to find it in one step calculation, better than using the area of rectangle and the area of triangle and then add them. Okay. Okay. So let's talk about the last trapezium we have here. What if you're asked to find from 12 to 16? If you're asked to find the distance from distance from 12 to 16. Huh. What do you think we should do? Huh. Some students choose to divide this shape into rectangle and triangle. تمام? Okay?
Yes.
Some students choose to divide this shape.
You can do it as a trapezium.
Others choose to do it as a trapezium. Wow. It's like a tilted.
It's 8 plus 12.
Yes, excellent. So here in this case, we're going to consider this side and this length is phase 1. Okay? And this one, consider base 2. And here is the height from 12 to 16. Yani imagine it's a tilted trapezium, okay? So here is the height. Clear? Clear?
Yes.
Yes.
Okay.
Yes.
So here from 12 to 16, it's a trapezium, base 1 plus base
2.
over 2 times height.
Height.
Base 1 equals 12. Base 2 equals
12 plus 8
8
over 2.
over 2
2
multiplied 4.
4. Excellent. Good
4.
girl. 12 plus 8 equals 20. 20 divided 2.
2 10 40.
Okay. Equals 4. Clear?
Yes.
Yes.
Finish the copying or screenshot this.
I'm done.
Okay.
Miss, I had a question.
Yes.
Like for the lessons, like عموما, how long would they be per day?
For the moment or momentum.
Pardon?
Sorry, you're talking about moment or momentum?
No, I'm asking how long the lessons will be. Just wondering, yeah.
For the first unit, you mean? I can't
And
understand your question. You mean how long we're going to take to cover these topics?
no, how long is each lesson?
How long is
Yani
each
session.
the time of the session?
Yes.
Okay. Started at we have been working only for 1 hour and a half our 1 hour and 15 minutes now. So it's 2 hours, and it's 2 hours from 10 to 12.
Okay, got it. I'm just
Okay.
wondering.
Yes, okay. Okay. So this everything is clear now?
Yes.
Does anybody have any problem, any question? Okay. So let's go to instantaneous. Instantaneous velocity or instantaneous or instantaneous acceleration. Okay. Instantaneous, any instantaneous quantity means this quantity, the value of this quantity at a particular instant. Okay. So for instantaneous velocity, it will be velocity at a particular instant. And instantaneous acceleration, it will be acceleration at a particular instant. Okay. Instantaneous velocity and instantaneous acceleration. Velocity at a particular instant, acceleration at a particular instant. How can we find this from a graph? Because always it comes to find it from the graph. Okay.
Okay.
So we're going to draw a graph. One is for distance time, and one is for speed time. Okay. Why here
Okay.
it's distance time graph? Because the slope of distance time graph gives us velocity. And why here is this speed time graph? Because the slope or the gradient of speed time graph is the acceleration. Okay. Is the graph is a straight line? Okay. And sometimes you're asked to find the speed t at a particular instant. Maybe t diet equals 30, equals 40, anything, any number, but it's a particular instant. Okay.
Yes.
Okay. So what are we going to do? We cannot find the from one point only, and we cannot find the speed at one point only. So what should we do? We make the gradient of the graph. So we should take a part from the graph, but make sure that the point you're asked about to be at the middle of the tangent, at the middle of this part. Okay. So here you're asked to find the speed at time t. Take a part from the graph, and the point you're asked about to be at the middle of this part. Okay.
Okay.
Find the gradient. As simple as that. Y2
Yes.
minus y1 divided
Over x2 over x1.
here. Take the reading from the graph is y1 Here is y2, and here it's x1, and here is x2. Okay? Clear? Clear? Any question, girls?
Yeah. No.
Wow. Okay. The same for the instantaneous acceleration. Okay? So here, if you're asked about the instantaneous acceleration at a particular instant from speed-time graph, you will follow the same procedures. You will take a point, assign a part of the graph, find the gradient. Okay? And it will be y2 minus y1 over x2 minus x1 to find the acceleration, the instantaneous acceleration. Any question in this part?
No.
y1, y2, x1, x2. Okay? And the surprise here, and if you're asked about the instantaneous velocity and instantaneous acceleration, and if the graph is a straight line, it's the easiest part of the square. What is coming is a little bit difficult. The same instantaneous velocity or instantaneous acceleration. But now we're going to have a different graph. It's not a straight line graph, but it's a curved graph. Here, the same, it's not a straight line graph, but it's a curved graph. And you're asked to find the instantaneous acceleration. So what are the procedures I should follow to find the instantaneous acceleration or the instantaneous velocity? If you're asked to
Yes.
find at a particular instant, it's maybe 30, 40, or time t, at time t. When you find in the question at time t, so it's at a particular instant, okay? So you understand that this is an instantaneous velocity or even instantaneous acceleration, because it will not be mentioned in the quiz, in the question. It will not be mentioned. And you'll not be asking about find the instantaneous velocity. No. The question will be find the velocity at time t. Okay, identifying a certain a particular instant. So here, what are the procedures that we're going to follow? You're going to find which point this time t intersect with the graph, okay? And then you will draw a tangent. Have you ever heard before about tangent? The word tangent, you know what's tangent?
Yes.
Okay. What is the tangent? Does anybody know?
The line, it doesn't pass through يعني through all the line يعني it is only
Excellent.
yeah
Bravo, يا لمار. Okay.
100.
Tangent, it will touch the curve at only one point. Okay?
Yes.
Okay, and it's a straight line because we cannot deal with the graph. We cannot find the gradient or the slope of the graph when the graph is curved. In gradient or slopes, we use straight lines, okay, or line segments, straight line segments. So we cannot use this curve to find the instantaneous or the gradient. So here we assign a part from the graph, okay, and draw the tangent, but make sure that this tangent and the point you use is at the middle of the tangent, okay? and then use the tangent you draw as if it's a here y1, y2, here x1 and x2. Okay, clear?
Yes.
Girls, Mariam, Fatima, Sayida.
Can you please repeat it?
Okay. To repeat which one? When the graph started or the instantaneous, all of the instantaneous part?
How did you find them? Like, I don't know. I did not understand.
Okay. Okay. Here, if the graph is curved, or this part also you don't understand. This part, the graph is straight line.
No, not this part.
This part, okay. So you're familiar with, or you're convinced with the idea of instantaneous. Okay. If the graph is curved, we assign the point at which you're asked to find the instantaneous velocity. Okay? So here,
Okay.
this is the instantaneous velocity
Yeah.
time t, a particular time. Okay? Find the point on the graph that you're asked to find the speed at which. Okay? Then you draw a tangent.
Okay.
You draw a tangent. What is the tangent? It's a line that's touching the graph at this point only. Okay?
Okay.
Here, if the graph takes this shape, again, and you're asked to find a time t, find this point on the graph, draw a tangent. Okay? Use the tangent as if it's the graph. Find the points y1 and y2, and on the x-axis, x1 and x2. Is it clear now?
Yes.
Okay. If you still just ask again, no problem. We're asking many more times. Okay?
Okay.
You got it? Sure?
Yes. Yes.
Yes, okay. Okay. So that's how we find the instantaneous velocity from distance time graph. Right. The same if you're asked to find at time t, you are asked to find the acceleration. So the same procedures will be followed. Find the intersection point, draw a tangent, take the reading from okay. So here the gradient, which equals the acceleration, will be y2 minus y1 over x2 minus x1. تمام? Any problem here?
Yes.
Nothing.
No.
Everything is clear?
Yes.
Yeah.
Okay. One more thing, we finish all the parts of the motion topic. The average velocity. Okay. What is the average velocity? Average velocity is the total distance over,
Total time.
okay? When we use the idea of average velocity, because the object, it's impossible for the object to move with constant speed for a whole trip. Okay, the body always varies its velocity or its speed.
Speed.
So
Yes.
we have here the average, the idea of the average velocity. So here, if we have an object, here it's distance time. And the graph is straight line. And another object is moving. Okay. Okay, so here we have two objects. One is moving with constant speed all over the trip, but the other is changing speed all over the trip. Okay, so the average velocity of these two objects will be the same. Why? Because average velocity is the total distance covered in a duration, regardless how the speed was, if it was constant or it was changing. Okay, so here if
Okay.
it's 10, suppose it's 10, and here it's 5. So they will have the same average speed. Will be 10, the total distance, over total time, which is 5. So it will be
Just two.
meter per second. This velocity or this speed is accurate for this object, the red one, the red graph. But for the second graph, for the green graph, it's the average speed, not the accurate speed or the constant speed the body moved with. Okay, the idea is clear.
Miss,
Yes.
Yeah.
can you please repeat it again?
Okay, average velocity is total distance over total time. Okay,
Okay.
if the body was moving with constant speed, so average velocity is the same as constant velocity. But if the body was changing its velocity during the trip, as you can see here, that the green part is A has a speed different from B, right?
Yes.
So here, for the constant velocity, it's the total distance covered regardless if the body was moving with constant speed or the body was moving with changing speed. Okay? And
Okay.
it's the same also if the body, if we have a third body and this third body was moving this way, the same.
Oh.
The distance will be 10 and total time will be 5. Although they have different speed, the three parts of the three graphs represent bodies that move with different speed all over the 5 seconds. Clear?
Clear. Yes.
Yes, okay. Okay. What if we have speed time graph? Here it's a speed time graph. And here you're told that here 0 and here 10. Okay, so here if you're asked to find the average speed, how can we find the average speed here? Here we'll find the average or the mean as if you have initial speed 0 and final speed equals 10. So how to find the average speed? So here in this average speed or average velocity, they are the same here. It will be V1 plus V2 over 2. Okay?
Yes.
Okay, so V1 is 0, V2 equals 10 over 2. It will be 5 meters per second, right?
Yes.
Here, the average speed is a value between the highest speed the body reaches and the lowest speed the body reaches. Okay? So here we use this formula, V1 plus V2 over 2, if the body was moving with constant acceleration. Here's the body is accelerating with constant rate. So you have V1, V2, V1, V2 plus over 2. It will give you, يعني, the average here, like the average of anything. If you have any two values for any quantity and you're asking to find the value, the average, you add them and divide them by their number. If you have 3 speeds, you will add them together and divide 3, right? Clear?
Yes.
Okay. But here for the first formula, we use it if the body changing acceleration. Okay? Everything is clear?
Yes, Miss.
Yes.
I got
Yes.
Does anybody have any question?
No.
No.
Sure.
Yeah, but I do have like, are there any sources that I can practice average velocity, or will there be homework?
Sure. I will send you a file for different questions. Sure. Who is talking? Fatima or
Fatima, yeah, me.
okay, I'm going to send you sure. Okay. Don't
Miss, I
worry.
can't hear you. Your voice is kind of far.
Don't worry. I'm going to send you files.
Okay, thank you.
And me, Miss. Okay, and me too.
Sure.
Okay.
Any questions, girls?
No.
Okay. So I think it's enough for today. And we're going to say to see and or to check what is if we're going to change the time. Is it okay with you or?
Yeah, Miss, can you please add me in the group?
Sure, you are. Who is talking?
I'm Sayeda Fatima.
Yes. Okay. I'm going to add you. Sure. Okay. What about the time, girls? Or let's stop now, and we're going to discuss about the time later. Okay.